This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring you information that will expand your skill sets and toolbox and share the stories of fellow network engineers.
Welcome to the Art of Network Engineering, where we are a complete, no-nonsense group of highly professional podcasters who always give well-thought-out information and opinions. I am Tim Bertino, and joined with me tonight is someone who may or may not agree with everything I just said, Andy Laptev. Andy, how are you, my friend?
Hi, Tim. Awesome. Happy to be here. Good to see you. Friendly faces.
Anything new or exciting this week?
I'm taking a deep dive.
Other than the fact that you're either standing or floating.
I am at my standing desk. I've taken a deep dive.
Marty McFly.
You ready for this? This is what I've been learning this week. It's a mouthful. Multi-protocol, BGP, EVP, and VXLAN.
Mm-hmm.
So that's what I'm up to. Yeah.
And you got it all figured out?
No.
Oh, okay.
You're the expert now.
I'm getting there.
Yep.
Yeah. So, yeah. Things are good, Tim. Work is good. Life is good. How you doing?
It's good to hear. I'm good. I'm getting close to the point where I'm starting to dig into WAN design in the InSalad portfolio. If only I knew a seasoned veteran of large WAN networks that could help me.
Dude, give me a call.
I'd have somebody to ask, but
I miss the WAN. I'm not in WAN anymore, and I'm all lost and confused again.
That's why I'm poking at you.
I miss knowing what was happening. Hold on, before we move on, I want to thank your wife for this beautiful piece of artwork that she sent me, which is our logo. This is very nice, and I haven't had a chance to officially thank you on the show, so thank you, Mrs. Bertino.
Yeah, those were cool. She found someone that does those, and she wanted to get signs made for a couple of the kids' teachers, and she got those made, and she gave the person our logo. I didn't even know about it. I got one for Christmas, and they were like, yeah, we'll give it a shot. I think they turned out pretty cool.
Yeah, they're really nice, man. So thank you.
No problem. Also with us tonight is Dan Howdy Packet Richards. What is happening, Dan?
Nothing much. Let me tell you something, though. Anybody with kids out there, they have these places that have trampolines inside, and they're in all kinds of crazy, like, you know, some of them are like slanted, and then they've got rows of trampolines and everything like that. I tell you what, if we had one closer to the house, I could probably lose some weight doing that and have fun with the kid at the same time. Because I am hurting.
Well, hang on. Do they serve beer?
You know, I didn't see any there, but
okay.
I don't know. Maybe I could bring my own.
Well, yeah. Granted, beer and trampolines is probably not a good idea.
Yeah, probably not.
Might spill your beer.
Maybe. Yeah. Maybe.
It's the ultimate test. How good are you at holding or not spilling your beer? No, I'm good, Tim. You know, I have my little plaque with our logo on it right there. And the last recording, I had it leaned up against the wall, and in the middle of the recording, it just like whoop, it slid down. So I've got to figure out a permanent mounting solution for it so that I can put it on the wall right there.
There
so
we
everybody
go.
can see it.
Show the pride, right?
Right, exactly. So yes, thank you.
And now it's time for some wins. Winning in our Discord channel this week is Adil Khan. He got 3 certifications this past week alone.
What?
My goodness.
Stop it. Stop.
It's the truth. He got his AWS CCP, his Google CDL. I don't exactly know what that is off the top of my head. I'm not too familiar with the Google certifications. Yeah. And he got the Oracle Cloud Infrastructure. So somebody has been studying a lot of cloud lately. Congratulations, Adil.
Stop, Adil.
Adil, do you
stop?
No more.
Do you even work? Like, where are you coming up with time for?
Do you
all
get
this?
paid to study?
Yeah.
My goodness. Network Hug passed the Pen Test Plus.
Nice.
Congratulations.
Nice.
Joey passed the A Plus.
There you go.
And
Yay.
River Haven't seen that name in a while. River has passed the Aviatrix Certified Engineer in Multi-Cloud Networking Operations. Congratulations,
Awesome.
River.
Good job, dude.
River.
And Pet Frong, I think. I feel like I should go back and look at that in the Discord. But they recertified their CCNA after 6 long years of being away. They are
Nice.
CCNA certified once again. Congratulations.
Nice.
Freshly minted.
Lots of new Patreons have joined us in the past week. Welcome, welcome, welcome to Tim Lowsbury, Michael Hilton, Jared Mock, entry level, JJ McLean, and Richie. Thank you so much for your support of what we do here on the Art of Network Engineering podcast. And if you're listening to this episode as it releases, it's not too late to register for the very first A1 Live. We are going to be in Asheville, North Carolina on April 9th from 4 to 7 p.m. at the Highwire Brewing, and you can come hang out with us. And we're going to record an episode live right there, and we're going to have a great time. You can find the registration link in the show notes for this episode. Again, that is April 9th. Come and join us. Also, we're doing a pop-up shop with limited swag that we don't have on our regular merch store. And this pop-up shop is tied to the Asheville event. But the great news is if you're not able to make it to Asheville, you can hit our pop-up shop, order your swag, have it shipped right to you. However, if you are going to be at the Asheville event, you could select the option to pick it up at the event. We will have the merchandise shipped there and available for pickup, and you can put it on or do whatever it is that you do with the swag that you got right away. And so look for that pop-up link as well. And as always, thank you so much for your support of everything that we do here on the podcast. We couldn't do it without you, and we do it because you support us and show us so much love. So thank you so much. Now back to the show.
All right, let's jump right into it. This is actually a sponsored episode of The Art of Network Engineering. We have with us this evening CTO of PathSolutions, Tim Titus. Tim, thank you very much for joining us on this episode.
Certainly. Glad to be here.
How are you this evening?
Doing well. Doing well.
So you have, I don't want to undersell you by any means, but you have quite the storied past. Do you mind, let's start off with kind of who you are, who PathSolutions is at a high level, because I know we'll get deep down into the weeds here pretty shortly, but kind of who you are, what PathSolutions is, and then let's take it back to what got you into what PathSolutions is today.
Well, when I was born, I was very young. Oh, wait a minute. Not that far back. So I've been a network engineer for over 30 years.
Oh, wow.
For those of you curious, that's back in the days of coax, ArcNet, thin Ethernet, little bit of thick Ethernet that I dealt with, but also Novell NetWare. I used to have to compile the operating system by swapping out floppies to actually compile the operating system. Back in the days when if you had a missing terminator on the end of an Ethernet cord, all of the packets would fall out of the cord and effectively you wouldn't have a network.
Would that be flooding? They fall out and start flooding? I'm just curious.
Yeah, bits spilling out all over the place. You'd have to come with a mop. It was terrible. I mean, honestly, it hasn't changed from doing janitorial type of work from back then to now. I mean, it's sad.
Nice.
But what I found is that back in the day, it's like troubleshooting was the bane of your existence. It's like you could say, gee, I could spin up a new server. I could do these really cool engineering projects, but you'd always have users saying, hey, I got dropped out of a database. Hey, the connection's slow. Hey, I'm having problems. And all of these problems was a mystery where you figure, I have to go start assembling the clues to find out what the problem is, to find out where the problem is, find out why the problem happened. And that whole sleuthing activity, I'm going to say, hasn't really changed over the years. And I found that kind of sad because you look at networking and technologies and going from those really old bus networks to star networks to Ethernet ruling the world, and then going to fast Ethernet, gig Ethernet, 10 gig, 50 gig, just the speeds going like crazy, capabilities, all of the VLANing, the routing, the capabilities of the networking services just through the roof. Yet troubleshooting really hasn't changed a whole lot. And I kind of looked at that world and said, that world needs to come to an end. There's too many cases where people are stuck saying, gee, I don't know where the problem is. I have packet loss somewhere in my network and I just don't know where. And I figured all of this should be automated. I dreamed of the day of saying, I just want some software that I can splat at the network and say, tell me all of your secrets. Tell me what's going on so that I can start troubleshooting and proactively solve the problem before users are affected. So that was really the idea that caused me to say, gee, if companies aren't moving forward doing this sort of automated troubleshooting, I got angry. I got frustrated and said, gee, I'm doing the same manual troubleshooting that the company across the street, they're doing manual troubleshooting. Everyone on this call, you guys are all doing manual troubleshooting. And it's like, why is this not better? And after a little bit of frustration, I figured that means that I should actually do something and solve that problem. And eventually I got the chutzpah together to say, okay, I'm going to quit my job. I'm going to found a company and create a product that specifically targets automating that troubleshooting to tell you the secrets of what's going on in the network.
Isn't it?
So that's just a little bit of my I needed to concoct this to solve my own insanity type of problem.
See, so first off, back then when you got your start, was there even anything that could give you some sort of a baseline of what, quote, good was and how slowness was determined?
You had some ability to do measurements. You'd have, forever people have had bandwidth graphs and say, gee, what's the bandwidth look like? Well, in order to get throughput, you need the bandwidth of every involved link along the path. Okay, that's a little bit more complex. How do you find out what all of those links are? Well, it's typically an engineer with tribal knowledge putting together saying, well, I know it's this link, this trunk port on this switch, this link on this router, all of these links and connections all the way through. And then you have to figure, well, if we have a router that's underperforming and it's having some CPU spikes and we're doing CPU-based routing because of a misconfiguration, or there is a spanning tree topology change going on in one of the LANs where it's causing glitches, and that's causing packet loss and causing the TCP sliding windows to slow down. So all of these things put together just means troubleshooting is darn difficult, especially if you don't know what you're looking for, because before you find it, you don't know what it is. Mm-hmm. But it's that there are clues out there that a senior level person can manually put together if they're able to catch it at the right time, at the right location, at the right spot. And I figured that rarely happens. And I think we've all encountered this where you say, gee, the problem happened and the user complained, and you look through and say, okay, I can't find what it is. And you just tell the user, maybe the next time this happens, we'll get a little bit closer.
Oh, the intermittent issue.
And
no.
The intermittent issue.
No.
And
at one time last Thursday.
Yeah.
At the worst possible time, your company's going through end of month processing and they're trying to ship extra stuff. And all of a sudden the problem happens again. Okay. And you go and look and it's disappeared by the time you want to look. So it's this sort of troubleshooting that just leads folks to be frustrated saying, I wish I really knew this network. I wish I knew what every piece of equipment knew. I wish I knew what every interface knew. If I had ultimate knowledge on this network, I could have an analytics engine tell me what's broken.
You know what's interesting?
The information's out there.
You know what's interesting?
So are you saying... Oh, sorry, Andy. Go ahead.
Sorry, Dan. What's interesting to me, this is the art of network engineering, right? But I've thought in the couple of years we've been doing this, the real art to this job is in the troubleshooting, right? Because how do you teach somebody how to troubleshoot? I mean, there's some basic things you can do, like divide and conquer and try to isolate. But like you said, it takes a long time to know all the intricacies of a particular network, right? And then you had said, like tribal knowledge, like we used to call that where the bodies are buried, right? Like, oh yeah, there's that one thing we built for that one BU because it was a super rush and we had to go out of the scope of whatever, and every once in a while this weird thing happens as a result. Like if you're a new person going in there and this thing kicks off that other people know about, you're the junior guy who gets paged in the middle of the night. Like, I don't know. And my troubleshooting from the time I was in the field up until recently was just, somebody calls and you're really just going, there's some kind of intuition almost that's like, okay, well, where could this be, right? What device should I start in? Let me look in I would always look at logs, right? Like, I guess if you asked everybody on this panel, we probably all troubleshoot differently. And that's, I guess, why we're paid and hired, is because we're the intelligence, I guess, right? Like, hey guys, figure this out. What's going on? Fix it. And it's amazing to me. It's taken decades for this industry, for somebody like yourself to come by and be like, there's got to be a better way. Why are we doing it slow like Andy? Why are we looking at each log and each interface and trying to find it ourselves? I've always wished that intelligence existed, because it's been up to us.
And the equipment has it.
Right.
I mean, there's counters, there's logs, there's all sorts of information trapped up inside of these devices that if you could just point a computer at and say, go collect the information, analyze it, and you tell me what's broken, and you sit back and you wait 10 seconds and the computer ends up saying, oh, your problem is that you have a bad patch cord plugged into this router over here. Go check the interface. And you go look at it and say, Cat 3 patch cord. Nobody ever checked the cable jacket on this one. Where did this come from?
But you know how long that would take for me to troubleshoot that in one of my data centers? To actually finally find the one patch cord that, like, nobody assumes it's physical, right? Like, oh, what's going on? Did anybody do a change? Is this a code bug, right? Like, we over troubleshoot things sometimes. Like, I wouldn't send a data center op person to go and just start plugging and unplugging cables and swapping cables, right? But your software would have the intelligence to tell us, like, go look at the patch cord. It might take me hours to find out that it's a physical problem, So I'm really excited to hear about this.
I think we all hear the go check the physical layer. That's where you should start.
Yeah.
That was
but in shared infrastructure, when everybody's riding, say a pair of WAN routers in an MPLS cloud with 10,000 clients connected, you generally don't go and start unplugging stuff, right? Like, at least in the data center. But if we have an intelligent piece of software that says, hey, go check the physical, I've been baselining this network for weeks and I think the problem's there. It's easier for me to get a DC ops person to go and unplug that thing. He's like, I don't want to unplug the WAN,
Yeah.
Yeah.
Well, if it's physically functioning and passing packets, and you're not having any physical error issues like FCS errors, you have no alignment errors, then you can kind of rule physical out and then say, let's start looking at data link errors. Let's start looking at network errors. Let's look at queuing errors. So all of that information is still trapped up inside of the devices. And that's really the part that I looked at and said is magical, is the devices know. Whether you have Cisco, a Juniper, whatever manufacturer of router or switch you have, even down to the lowly, D-Link and Netgear, as long as it's a business class device, it has all sorts of SNMP information trapped up inside of it. It's a question of, do you want to go manually collect the error counters, manually go collect routing tables, bridge tables, ARP cache, spanning tree, performance information, configuration information off of all these devices, and then sit down on a huge network and say, how do I make sense of all this data? Or do you want something automated to go through and say, here's all of the clues, assemble it for me, tell me what's going on? And that's really kind of what we've designed, is something that will automatically collect, automatically instrument, automatically analyze to say, here's the root cause of your problem. Here's why you're having slowdowns when you're connecting to that one service.
Gotcha. Now, can we ask? So when you say analyze, is it all based on SNMP, or do you guys have the config so that it has some intelligence there that it can look through what, how the device is configured versus some of the SNMP traps versus maybe some syslog, maybe something else? Like how does the brain work, I guess, on this one?
How does the brain work? I can't tell you the secret sauce.
Yeah, that's okay.
I don't even know how this brain works. But so our inputs are, we're going to do SNMP, and we can do SNMP v1, v2c, v3, as well as Cisco's high encryption V3 of Triple Des, AES 192, AES 256. So we'll support the world on SNMP. We also take in syslog, we also take in NetFlow, and we will take in configs.
Okay.
So in one sense, what we're going to be able to do with all of this knowledge is analyze all that to say, here's what it would take a CCIE 4 hours of analysis to find out what's going on, and we'll give you the plain English answer. And
Gotcha.
that tends to end up saving a lot of organizations a lot of time. It also means that, I'll admit, I haven't found a senior level engineer yet that loves doing trouble tickets. Ooh, I get to do tickets. No, they want to work on strategic level projects. They don't want to be given this ticket saying, here, find some packet loss because we have call quality problems. And so if these problems can be solved by the junior level person saying, this interface over here has a VLAN tagging fault because it has an MTU mismatch, that's where the problems are happening. They can fix that one problem and it never needs escalating. Also, the problems get fixed a lot faster because it never needs escalating. And all the information is brought to bear so that problems get solved more faster by junior level folks.
Gotcha.
God, that sounds amazing. Wait. So I'm thinking back when you were a junior level folk, right? Like you said, way back in the, the coax ThickNet days. Because I think you're fascinating. It's not that many times we get like a guy with 30 years experience, right? As like a network engineer on the show. And I definitely want to circle back to like your product and your solution. But I'd love to get a little bit into your history of your job if we could, just for a brief moment, because you said like, yeah, I've been in 30 years and the stuff was old and all, but like, how did you get in? Because a large part of our audience is like, how do I get my first job? How do I break in? Do I get a certification? So if at the very least we can just hear how you got your start, where you're a computer science guy.
I'm perfectly happy sharing the story. Although I will freely admit that I think the world is different now than it was 30 years ago, but this is maybe one entrant, one way of getting in is that there was a company, the semiconductor company in Silicon Valley that was growing like crazy. And they looked out and said, hey, we need to build a new building and we need to get cabling done. And they realized that to pay a cabling company to do the cabling infrastructure, they said, we're not willing to pay the $500,000 to end up getting a cabling infrastructure built. And this company was kind of scrappy in one sense, is they said, go hire some college kids and go teach them how to do cabling. And I was one of those college kids that just said, sure, I'll do anything. And I dove in, I learned about cabling infrastructure, learned about 66 patch system, 110 patch system, learned how to crimp ends on cables, really learned everything about layer one in such extreme detail. And by the time we finished the building, it was great is we found I think it was something like 1,000 network connections that were made. There was only one connection in the building that was miswired.
Wow.
So
that's impressive.
We ended up doing
a record right there.
Yeah.
Especially for a bunch of college kids that didn't know what they were doing when they started, right? That's impressive.
Well, okay. So I'll add, fear helps. when you are scared saying, I don't know if I'm doing this right or not, and you do it slow enough and methodical enough that you say, I want to make sure that none of mine are bad. So, okay, if it's bad, it's the next guy. And actually, I don't remember who it was that had the one bad connection. I think nobody really told who did that one bad connection because it was just pretty amazing. But, going slow and methodical and just doing it right the first time meant we don't have to go back and redo it. And I'll admit, I learned from that is that if you hire willing and dedicated college kids to do things and say, you're going to learn a skill from this that is really going to aid your career. I mean, it wasn't just cabling for network. We did cabling for CCTV systems. Back then, it was a separate system than the networking. We did the phone system. Also, back then, separate wiring system, separate cabling system. We also installed alarms. And so it was really, we did everything for that physical plant. And it was just amazing, the speed and things that we learned. And yet they got us to work 10, 12-hour days, weeks on end, because we figured the amount of learning we were having was incredible. So I guess my first suggestion to somebody who wants to get into this career is find a company that they might say, gee, we want you to work 8 and 10-hour days. It's like, yeah, that's fine. But make darn sure that is a company that is going to teach you skills and they're going to have the proper mentor to teach you those skills so that at the end of the first year of employment, you are worth double of what you were paid previously. And that just means that at that point you can say, okay, if they don't offer me a raise or offer me a new position that's higher level based upon the fact that I am now fully skilled, and also I have the tribal knowledge of knowing every bit of cabling that went into that building, I was incredibly valuable to them. And actually the team of 4 of us were incredibly valuable because we could go find any piece of cable in a second. So make sure you get
nuggets right
trained.
there.
Do you feel like learning all that physical infrastructure helped you become a better network engineer as your career progressed?
So yes, absolutely. So in one sense, you look at the 7-layer model and say, wow, there's a lot of complexity here, and I don't even know how to attack it. By the fact that they took us in and said, we're going to teach you building cabling systems, cabling infrastructure, learn how to count the wires. You have the color codes of the wires, and also do that for 25 pair, do that for larger cabling infrastructure. I look back at all that, and it's really was foundational to me being able to say, I really know everything I need to know about layer 1. And it made it so that when I started looking at back then the Novell NetWare, saying, okay, I'm going to start learning about hubs and switches and what happens at that layer, a lot easier. And then eventually it's like, okay, now some larger networks, and you get into routing, and what is the purpose of routing? And so learning in stages was so important. In some senses, you get a lot of stuff just force fed down your brain, and it's like, packets and frames and routers and switches and all that stuff just jumbles up in your brain. If you could just focus on layer 1 for a week, and then focus on layer 2 for a week, and then focus on layer 3 for a week, it locks it in so that you get it as to what happens at each of those layers, and can say, okay, is this something that is likely to be a layer 1 problem? Or is this something likely to be a layer 2 problem, or layer 3, 4 through 7? It allows you to compartmentalize and troubleshoot a lot better.
What were you?
Yeah, I really appreciate that methodology. I do have a question though. I know you said this was a while ago, but it does sound like you made a lot of cables. Have you regained the feeling in your thumbs yet?
Yeah, because you didn't have the easy ones, did you? The ones that go through the end of the RJ45 connector.
No, it was manual trim, and you're trimming and cutting and trimming and cutting, and you'd goof it up, and then every single one you had to do a cable test, because there was just so those there doing the cabling was you had to do a cable test of those, because it was just too much chance you're going to go wrong.
See, that's all I've ever done. I know that they have the ones the cables go through, but I had a trick with my thumbnail that's how long the wire needed to be when it went into the ice cube, so that it would be the right,
yes.
so it would be the right length, so that the jacket would catch in the thing. And and maybe that's just my background, Tim, but I hear people, I try to pound on physical lab, learn the physical. It's important. It's helped me in my career. And it gets poo-pooed. Like, who needs that? That's ridiculous. I have data center people for that. But there's been so many outages I've worked, and I have a DC ops person remote somewhere. And it helps me because I'm trying to get into their head, see what they see, because we're working the problem together, and they may or may not be all that skilled. So to me, I can always lean on that physical infrastructure background. I think it's made me a better engineer.
Well, agreed. Physical layer is always a place to start. And something I'll share as well is when I left that job, I think I spent 7 years at that company. When I left that job and joined the next company, I worked for a far smaller organization. And I got to say, you feel real insecure and real scared when you start your first day on the next job. And it's like, oh, hey, this is our new IT manager. And it's like, oh, they're going to fix all the problems. And you're like, yeah, I'm going to fix all your problems. Oh, I don't even know your network. And I figured, what's the first thing you do? You step in the door, and the very first thing you should do is meet the people. That's actually the most important part. But the second thing you should do is visit every cabling closet and start understanding the physical infrastructure. Mm-hmm. And if you start documenting things and saying, oh, okay, there's a switch over there. This is this closet. It services this building. It services this floor. And you start just taking notes and you get the first week of your work is getting that physical layer understood, your next week should be, okay, let's get some switches where we log into switches, start understanding what's going on at layer 2 and then layer 3, and you start working your way up the stack. At that point, I was able to say, gee, I feel like I have some confidence of understanding this network because I know what we have. I know how things are connected. I know where the tribal knowledge is, the skeletons are.
Yeah, you finally see what you're working with, basically.
You must have had so much troubleshooting pain as a network engineer, because for you to be incited to create a company and build software to solve it, I mean, you must have some great stories. I'm thinking back to my longest, I think it was 26 hours of a maintenance window.
So here's one that's, in one sense, it's insidious, but it's a crazy story. So we had a user that was connected to the network, and they say, yeah, they're connected, but it's incredibly slow for just them. And I figure, okay, well, let me find out what's going on. Go back to the physical layer, find out, okay, there's link light in the closet. Check the switch port and say, okay, this is linked at 100 meg. Okay, that's not too bad because they're just doing web browsing. 100 meg for web browsing should be fine. But they're still having a really slow connection. I check the utilization on the switch port, find out, gee, it's using like 2%. So there's no problems with utilization. Okay. End up spending a bunch of time thinking about it. Eventually I say, well, let me go to the user's PC and see what's going on. Maybe they have a mini hub in their office or something. Nope, no mini hub. They're plugged directly in. And I stumbled across the fact that their network connection showed as connected as 10 meg. Well, wait a minute. They're connected as 10 meg with their network connection. They're connected as 100 meg on the switch port. How does that happen? And I sat there and stewed for probably 5 minutes until I realized that somehow this connection goes back to something up in the plenum. Got a ladder, popped into the plenum, looked around, found a switch hiding out there. There's a little 10100 switch, and it's like, oh my God, who puts a switch up in the plenum?
I've seen that happen. I've seen it.
Yes, that's sad. It's sad that multiple people have seen that happen.
Yeah. That's crazy. So going back to PathSolutions just a little bit, you were talking about, you use a little bit of SNMP, you use a little bit of syslog, little dusting of the config, how do you, so what I'm trying to get at is what I've experienced with typical, network monitoring systems and stuff like that is the alerts from them, right? Like you get an alert saying that, hey, ping is down, or, this power supply is acting weird. Like it's not seated or something, and you have to reseat it, right? But what you're kind of saying is that the PathSolutions will kind of figure out what might be the issue and send that alert to you rather than just saying, hey, this interface is down. Just thought I'd let you know, that kind of thing.
Yeah.
So that, to me, that's like, okay, now we're going into the next level of a network solution, right? Or a monitoring solution. So can you explain that a little bit? How does that look to an engineer, right? Like if it's figured out something's wrong with the way I configured OSPF, or like you were saying, weird errors on an interface or something like that might be linked to a misconfiguration of some sort. What does that look like to us?
So I guess what I'll do is before I specifically answer that question, I'll back up a little bit and talk a little bit about how we do what we do.
Okay.
So we're going to go out and scan the network. We're going to find all of the SNMP manageable switches, routers, gateways, and firewalls. That happens really within the first maybe 30 minutes of deployment.
Okay.
As we find those devices, we're then going to start asking, what are you? Okay, this is a Cisco Nexus switch. This is an ASR. This is extreme, an extreme black diamond from years ago. So we find out what that device is. We found an old 3Com switch. So we find the stuff. We then find out what is it, and then what is it capable of supporting. And really what that means is we start digging around with SNMP to see what MIBs it supports, what OIDs it supports, what information does it have that allows us to learn from it. And if it's a Cisco Nexus, great, it probably has QoS counters. Let's go see if it has QoS set up on interfaces. So there's a huge bridge branching path that we take based upon the OS or the manufacturer, the OS, then the configuration. And so we'll dig at the device to find out what does it have for us. At that point, then we start putting that together with syslog information, NetFlow information, and say, okay, these are the clues we can get off of this device. Based upon those clues, we have a heuristics engine. Now, the heuristics engine is actually this huge tangle of code that's really we've had around for really the inception of the company. We started the heuristics engine really early on because we figured, okay, we want to start solving problems. Let's just keep adding problems to this so that it gets smarter and smarter every single year we do a release. And at that point, we're able to end up splatting a network where we install, it's scanning the network, it's finding out what you have, it's finding out what the problems are because it's able to properly interrogate the devices to say, okay, you have this type of device with these types of error counters. Here's what it's trying to scream at you. Here's what it's trying to tell you. It has a VLAN tagging fault and you have an MTU mismatch and you're dropping 30% of the packets. Okay. In that case, we're going to give an alert and send an alert out that instead of saying, gee, you're dropping packets somewhere in the network, we're going to say, along this path, you're dropping packets on this interface because of an MTU mismatch. That way, junior or senior level engineer, the problem has already been found and diagnosed. Resolution can now occur.
I have two questions.
That's incredibly valuable.
Is the discovery automated? Does it just go out and crawl and LLDP, whatever it's doing? Okay.
Again, the dream is you splat some software on your network and say, tell me all your secrets. And actually, we've had some of our customers, they use us in what's called our tech expert mode. What that means is they deploy it on a customer network, let it run for an hour. They come back and say, okay, here's everything that's broken. And they can print a report out, sit in front of the customer and say, okay, let's go through, kind of like when you bring your car in to have it fixed by a mechanic. Let's go through everything that we want to fix. It'd be 30 minutes to fix this problem, an hour to fix this problem, 5 minutes to fix this problem. And you go through with the customer and say, here's our billing. Do you want us to go do this now that we found all the problems?
Do I have to allow
Nifty.
you in
Whereas,
the VTY ACLs or like, how do I allow your
just
engine
SNMP and SSH.
Okay.
So in one sense, I'll admit, we are going to replace a standard network monitoring platform.
That was my next question.
We have folks that have,
you're not running in,
they have old school.
You're not running with Spectrum.
Yeah.
Right? You're tearing something out and putting this in.
Yeah. I mean, you can run us alongside of it because in one sense, most of the old school monitoring solutions, they just don't go deep enough to tell you what's broken.
Absolutely. Yeah. You're just going to get a trap.
They'll tell you about an outage.
You're just going to get a trap.
They're great at,
right.
Yeah, a trap or an outage. It's like they're great at outage detection. The problem is the world has moved so far beyond outages that it's like, why am I having a route flap?
Okay, so you do all that plus all the intelligence and going deeper.
Yeah,
cool.
So we'll do configuration management. We do network diagramming. We'll do all of your net flow, path mapping. We have a voice module that does call simulations, so we can do APM types of tests. Wow. We also have a work at home solution, so I can end up measuring all of your guys' wireless signal strength. I can tell you about problems with SSIDs. I can tell you about your neighborhood. So it really kind of automates all of that sort of stuff. So we can say, gee, do you realize that you're in your neighborhood, everyone's using wireless channel 6 and nobody's using channel 3, and if you switch to that, you're gonna have it all to yourself. This sort of stuff.
So is that an endpoint agent at that point?
It's an endpoint agent. Okay. Yes.
Okay.
I do have something that I wanted to jump into. You'd mentioned configuration management, and that's something I'm pretty passionate about. I think it's really important. Can you kind of dive into that a little bit? Am I with PathSolutions configuration management? Am I getting reports when there's changes in the config so I can see the side-by-side config difference and who did it? Yep. Is that part of that solution?
Yep.
Okay.
So we'll back up the configs on a regular schedule. So like Friday at 8 p.m., we'll do the full backup. Also, if somebody goes in to make a configuration change, we're going to detect that change, immediately go perform a backup, do a diff against the previous backup and say, here's the two new static routes that were added to the core router and who did it. And then send an email out to the team saying, here's who just made that change and what the change was. So that if there's problems, everyone knows what needs to be backed out.
So it's a nanny.
There's nowhere to hide.
It's gonna tell
A
us.
finger
sadly,
point.
Dan
nanny.
did it.
Blame.
It was
blame
Tim.
is, yeah, it's still
It
a
was.
popular
He's not
feature.
wrong. No, I think that's such an important solution because I'm not going to spout off a fake percentage here, but I mean, how many times does something break or something become affected because a change has happened in the environment? Or you want to know if there's going to become configuration drift over time. So I really think that configuration management, backup, configuration differences is super important.
I got a question.
But it's also people lie. Oh no changes were made.
Yeah. I was about to
Yeah.
say. Here's another thing too: is if myself, if I know my changes are being logged and people are getting alerted that I made a change, I might be a little bit careful on what I do.
Yep,
You guys know me. I'm a send it kind of guy, and if I know, like in our Meraki setup, we have it set to where anytime we make changes and stuff like that, it emails the group saying that such and such network changed. Here's what changed, and it was changed by this person.
Except when it's your sign in, right? You've got that.
Exactly. That's the beauty thing of being the admin.
Yeah, you
go. No. So just knowing that you're being logged on that kind of on that level, right? And it's being alerted to people, that kind of makes you want to,
Related to configuration
sketchy, right?
changes like that.
Yeah.
Back when I was a network director, I had a team of network engineers, and at the end of the year, there was one engineer that I awarded the Fat Finger Award.
Oh, nice!
Oh my god!
The oops, they typed the wrong route in on the router for the new route to go in, and just goofed up routing for an entire organization.
It happens.
Nice. Hey, I want to go back just a little bit. You said your scan will look at the OIDs or however you say that. I think you said it. How would you say that?
There's no standard. Go ahead, go.
OIDs, yeah, but yeah. Anyways, so let me get this right. Do you have to manually put in OIDs for things, or does?
Oh God, no.
Oh my gosh.
Oh God, no.
Well, you got me sold right here.
Yeah, the whole purpose is, okay, if we look at technology as it moves forward, technology tends to make other technology disappear.
Yeah.
Do you guys worry about how to apply the choke on your car to start the engine and how to apply the No, technology has been done to automatically deal with that, whether it's cold or hot, and the engine just starts.
Yeah.
So if you can have technology that makes other technology disappear, then you're moving forward. And so that's what we're doing, is we're eliminating all of the SNMP. We just need an SNMP community string or credentials to be able to get access to the box, and we will automatically interrogate the box and tell you, you've got this problem on this interface. You've got a missing default route on this device, and it's sending packets off into the loopback adapter. This sort of stuff.
Okay. Am I the only one who has struggled with trying to figure out what the OID is for certain devices, or is that a common thing? I don't know. I feel like it's a common thing, but
common.
It is common. And the thing is that having people have to learn, where do you find the data? I mean, I'll admit, I spent half of my career digging around to say, where do we find the data? Oh, this set of OIDs or OID is deprecated, so you have to find it in the new location. Oh, this isn't provided in the MIB2 standard section. You have to go in the private enterprise section. And you're just digging around forever, hoping that you stumble across it, doing massive Google searches to try and find out, where do I get the data? And I figured, again, that day and age needs to come to an end, where all this information is brought back and normalized to say, oh, if you have a Cisco router, we know how to collect the information off of that. Yeah. If you have an Enterasys, old Enterasys box, we know how to get the information off of that. And so whatever the equipment is, we can dig at that and say, here's what it's trying to tell you, so that you never have to deal with specific OIDs ever again.
Yeah.
So the magic is just built in.
Yeah, that's awesome, because I personally don't have time to sit there and try to dig and find OID numbers for, I need to know what the temperature is on a Cisco switch kind of thing, and so knowing that this kind of just does that automatically, that's all right.
I know.
All right,
Dan's
Tim, you got a check from me right here. Like, we're checking off of things on my list here.
Dan
Hope it's a
doesn't
big
have
one. I
time
wanna
for
buy
that.
the
He's got anonymous config changes to make.
Yeah, exactly.
So Tim, I think we can all agree that having, as complete network visibility as you can get is awesome, and it's really important.
Actually, our moniker is total network
Total
visibility.
network
So you
visibility.
were
Get it
close.
right, Tim.
Sorry.
Tim.
It's a sponsored episode. I can't get it right. But
okay.
while that total network visibility, don't turtle your network, by the way, I'll add that plug as well. While that's really important, I think there's also something out there that's called alert or alarm fatigue. So, and that's when you're just getting so many alerts throughout the day that you don't know what to focus on. So how does PathSolutions, how do you handle that? Like in an access layer switch, I don't need to know if somebody walks up to an access port and plugs it in, unplugs it. I don't need all those alerts, but I definitely want to know if you can't reach a loopback or uplinks go down. So how do you handle that alarm fatigue with PathSolutions?
So, in one sense, setting global alarms is the thing that people are scared about doing, because you're right. You set that global alarm and say, tell me if any interface changes status. And I will admit, we do have some government entities that use our software that want to know if a single interface anywhere in the infrastructure changes status, because that's a security concern.
But do they have a person that just sits there and looks at that? Because I can't keep up with that. Exactly like what Tim was saying.
No, they have networks where nothing changes and nothing should change.
Could be a spy.
Oh, okay. Yeah.
Jason Bourne just plugged an access layer in.
I got you.
Yep.
That makes much more
within
sense.
Within 10 seconds, he's saying, I'm in.
Yeah.
That's the magic Hollywood, hacker, 10 seconds and then I'm in.
Yeah.
So the global alerts are something that a lot of organizations fear. And what we've done is we've made it so that you can still have global alerts, yet they get squelched, because you can say, let's make it so that if any interface in the infrastructure has more than 10% packet loss, I actually do want to know about that. That is something to say, help desk, go out, fix that problem, because that user is going to complain about a problem, because 10% is enough that you can drop a connection, you can have slowdowns. And so that's that threshold. If any of my infrastructure interfaces, meaning trunk ports, router to router connections, links, anything that is part of the infrastructure has more than 4% or 3% packet loss, I want to know about that, because generally that means that you're going to start having voice issues, unified communication, anything that is real-time protocol, you need to be concerned about. If I drop any packets out of a high priority queue, your queuing is set up so that you should have enough queue space, enough queue depth for all of your high priority protocols. And if you're dropping packets out of that, it either means you have a misconfiguration, or you need to add more queue depth, or you need more bandwidth. So knowing about that is something that you can say globally, I want to know about queue drops, or queue drops only on high priority queues. So you can do some global things with these alerts that are a lot more smart, I guess, compared to a lot of other products where, sadly, a lot of folks install network monitoring and they say, well, what does it get to you? Well, it pings things, so I know about outages, and I got a nice utilization graph on my WAN link, but they don't know much else. And that's because of the amount of effort needed to build out collecting information and then interpreting the information manually. And I figured it's kind of like the new toy that you set up and say, hey, I spent 15, 20 minutes setting this up. I want to play with it. If it takes 4 hours to set the toy up, nobody's going to end up having fun with that. Nobody's going to benefit from that because of the amount of setup time.
Right. That's me.
Is all of your IKEA furniture unpacked and actually assembled?
So this is easy to set up? Is this like an appliance run as a VM somewhere? Or?
So it's actually a 90 megabyte Windows installer. So this will install on any Windows machine. Typically, our customers put this on a virtual machine. One of the benefits is that it's far more efficient than a lot of other products. There's no bloatware here. In our development lab, we have a giant sign saying no bloatware, meaning that it's all coded in C and C++. So it's actually very fast on lesser hardware. So there's a lot of other products that they say, oh, well, you need a 4-way box or an 8-way box at a separate database server. You need 24 gigs of RAM, all of this resource for their monitoring software. And we can actually get away with like a 2-core processor, 4 gigs of RAM, and 20 gigs of disk space. And we're going to be a lot snappier in performance based upon the fact that we're just far more compact and more efficiently coded.
Wow.
That's crazy. So do you just have a single monitor? Do you need to have multiple monitors? Does it depend on the design of your network? Like how does this design
So
look?
typically, I'm going to say a single monitor is really everything everyone needs. So you don't need to have multiple monitors. Even across WAN links, you don't need to have multiple monitors. And the reason is we designed this back in the day, and I'm going back to history again, of fractional frame relay links, the 64K fractional T1 links, the 128K links. We can collect information across those narrow bandwidth links and not flood the link. And the reason we can do that and other products can't is that other products will send a flurry of SNMP packets to collect their little bit of information. We figure, we have a 5-minute window. Let's slow collect the information. Go get us all of the OIDs for interface number 1, and then we wait. Go collect all of the interface number 2 information, and then we wait. Interface 3 information. So within a 5-minute poll window, we're going to get all 48 ports on that switch, but we're not going to flood the link, and we're not going to overpower the device by hitting it with a whole bunch of SNMP requests at the same time. So we're really designed to collect the information the way a network expert would want it collected, so it doesn't cause CPU spikes on the devices and won't cause bandwidth spikes, and yet you still get far more information than you get off of other products. So we're well behaved, I guess. That's the summary.
Nice.
Is it easy to manage and maintain? Like if I have to install this and now it's my baby, right? Like Andy, that thing's yours now. Now, like, are there upgrades? Do I have to upgrade the code? Is it just set it and forget it? It's pretty much leave it alone.
So I've been in operations for too long, and so it really is. It's set it and forget it. If anything, if one of my engineers comes up and says, "Hey, I just want to have this manual routine," no, nobody wants to run that. So eliminating the maintenance of the tool is kind of that's paramount. You don't want to have a tool that sucks 5 hours of your time each month just to have a payback of maybe 20 or 30 hours. That means you only get 15 to 20 hours worth of benefit. I figure if we can reduce that to as close to zero as possible and make it so that it's helping you solve problems that would normally take days or weeks to solve, and you spend 5 minutes saying, we found the cabling fault, we fixed it, and the problems just disappeared. That's really the magic that I want our customers and engineers to have, is the ability to solve the problem before the user complains about it, or to be the magician so that when the user complains about it, they have it solved within 5 minutes because they know their network.
You're speaking to me right now, Tim, because one of my coworkers, she's the one who's like working on our monitoring system. And when you're talking about taking time to just sit there and maintenance the tool and figure out the tool and get it, tuned the way you want it and everything like that, that's what she's dealing with right now. So,
and what's sad is that tool that they probably have, I could hide a half duplex 100 meg connection somewhere in the network and it would never be aware of it.
Yeah, probably.
I could have a QoS misconfiguration, never be aware of it. I could have spanning tree topology changes and never be aware of it. It's all of these monitoring solutions. There's so much they don't know that people end up getting trapped by. A user complains about a problem. You check your monitoring solution and it says everything's healthy. What's the problem? The problem is there's a disconnect between what's actually happening on the network and what the monitoring system is aware of. And if the monitoring system is aware of only 5 elements of information and there's 100 elements of information available, that's a lot that goes missing that you have to manually go collect.
Yeah. Now, let me also ask this. You were talking about a work from home agent that I would assume, does it run in the browser or does it run on their machine?
We have 2 versions. We have one that runs on the machine. It can collect all sorts of depth of information because it runs on the machine. But we also do have a browser solution as well to help troubleshoot the work at home users.
Now, do you guys have like a server edition where maybe you can like monitor server to server kind of traffic, or is that not something you guys are looking at right now?
So we can monitor Windows servers. We can monitor services. I don't know if I'm going down server and services, because we do also ingest WMI information. So you don't need agents on servers.
Yeah.
So we can monitor the servers. It's really a full-fledged, fully capable network monitoring and management system.
Okay, gotcha. We're just kind
There's
of
also another.
Go ahead.
Go ahead. There's also another module I didn't even mention, which focuses on security. We kind of realized a couple of years ago is that the amount of knowledge, the depth of knowledge we have automated, brought into the network would really be fantastic for security. So we figured we'd create reports and capabilities that allows us to have a security module as well. So we're able to tell you about vulnerabilities, policy errors, policy violations, I should say. We have SOAR built into the product, so we can do SOAR activities. So geographic risks, exposures, rogue devices. So really all of your IoT devices, where are they? Who do they talk to? So a full-fledged security package as well.
Nice. And I guess it has its own alerting and everything like that. Does it have like a separate dashboard or anything like that?
Yep.
Okay.
It has its own security dashboard.
Gotcha.
This might be a
So I want to keep digging into these, what I'll call kind of non-traditional network monitoring features that you have within the PathSolution suite. And I want to start next with, you have a feature that deals with VoIP troubleshooting. Can you kind of dig into what kind of value you get out of that feature?
So if you have two phones on a network and somebody comes up to you and says, hey, I had a call quality problem at 2:30 in the afternoon. What happened? Most network folks will sit there and say, there's nothing in my logs, and my utilization graph on my WAN link looks pretty good at that time. And that's as far as they can go.
Yep.
That means you can't solve the problem, and you have to tell the user, maybe the next time this occurs, I might see another clue. And realistically, this means the problem has to go on and on and on until they escalate with their boss, and then you're having your boss breathing down your neck, and now you're logging into switches, logging into routers, randomly searching the network, hoping you're going to stumble across what the problem is. So we figured automating this means that we can tell you between that phone and the other phone at 2:30 in the afternoon, here's what was happening on every link, every switch, every router, so that you can look along the path and say, oh, we had a QoS misconfiguration on this interface, and it was dropping 6% of the packets out of the high priority queue. And 2 minutes later, we were dropping packets due to a bad station cord for the far end phone. So this was two problems that were happening along that path, that if you solved one of them, yeah, you'd solve some of the problem. But recognizing that some of these troubleshooting issues, and I think we've all encountered this, is the troubleshooting issue that's actually multiple problems working in concert. Those are the ugly ones. We can pinpoint that and say, here are the two problems that are occurring, so you can get the root causes of the problem solved really within minutes of the person saying, I had the problem. Or better yet, we can send you alerts on that so that you can tell the user, hey, I'm already working on fixing the QoS issue, and here's a new patch cord. I'm going to put it in on that far end phone. And thus you tell the user, we're ahead of the game because we know what the equipment did to mangle your packets. Also on the VoIP side, we have a call simulator that will simulate voice traffic across the network, so you can find out where do we have latency, jitter, packet loss, out of order packets. And by the way, I'm on a huge soapbox about out of order packets in that networks are far more resilient than they've ever been. Outages are far less, but the reason the outages are less is there's more paths to get to the destination, more paths at layer 2, more paths at layer 3. That ends up creating more chance for out of order packets. Well, out of order packets for data is fine. The transport layer will just reassemble them. Out of order packets for real-time protocol sound like Yoda we would. You can't have out of order packets. So finding out where do you have the out of order packets, when do you have the out of order packets, so that you can say, okay, let's put some proper per stream load balancing on those layer 2 links. Let's put some per stream load balancing on layer 3 links so that you're not having those out of order conditions. So we have a call simulator that can help you find where those problems are happening.
Gotcha. Now, will it actually hit real phones, or how does that?
It can target real phones.
Okay. Gotcha.
It's effectively what we have is we have a patented technology that uses ping packets that are wrapped inside of a G711 codec packet, or you can choose whatever packet you want. And we then mark that packet with DSCP. So according to the network, it looks like a G711 packet. According to the destination, it looks at it and says, oh, this is a ping packet, turn it around and send it back. That way we can target midpoints. So we can target a switch, we can target a router, we can target the far end router. So you can test just across that WAN link. Then you can test all the way end to end, and you don't need a remote agent.
Very nice.
Yeah, that is really cool. The next thing that I wanted to talk about is something that I know Dan and I at least have gone back and forth on multiple times with our mad Visio skills, and that is static network diagramming is difficult, and if you don't keep up on it, can it quickly become a waste of time because it's meaningless after a certain period of time if you're not constantly updating it with changes. PathSolutions has a network diagram tool within the product. How does it work, and what does it look like?
So again, it's that we realize we have this incredible data set of information that we've automatically pulled from these devices. What can you do with it? Okay, we can do path mapping. We can do root cause troubleshooting. We can also do diagramming. So we added diagramming, figuring we have all that information. We have the routing tables, bridge tables, ARP cache, spanning tree, all of that information to put together to say, here is the topology of your network. And you can just download it to Visio. You can use it to move elements around, lock elements in place, search for things. If you have a particularly large network and you're thinking, what is the purpose of the 10.51 subnet? Where does that exist? And it will help search and say, oh, that's located in the Austin office, and that connects the Round Rock switches. So you always understand where things are in a large and complex network.
That's pretty cool. Especially for like let's say we're talking about like a new junior engineer or something like that, and they don't have that tribal knowledge of even if it's just a medium-sized network, right? And they need to figure out where something's at. This could be a search tool for them to not go bug the senior engineers, right?
Yeah. Back in my day, I had to CDP the hell out of everything.
Yeah. Had Notepad plus and CDP everything.
Yeah. That's another thing is we take in CDP and LLDP, and that's another way we learn about things in the environment. So we'll pick up the CDP information and say, hey, there's a switch out here, or there's a device out here. And that's another thing we looked at a lot of other monitoring software packages is they don't benefit from that CDP or LLDP. And we figured it's knowledge. Bring the knowledge to bear so that somebody can say, oh, that's what's connected out there.
So basically what I'm hearing is PathSolutions, you're soaking up all this data that's out there on your network, and you're putting like a CCIE mindset on what might be causing that issue, right? Is that fair to say that?
Yeah.
Okay.
Yeah.
All right.
So you really discovered the trick is that if you have a junior level engineer, they can start solving problems within the first hour of deployment because we found and diagnosed them. A senior level engineer is going to say, oh, happy day. I don't have to go through all of these logs. I don't have to sift through SNMP. I don't have to spend hours and hours and hours. I've got the problems found and I can verify that, yeah, it made the correct analysis and go solve problems today.
Gotcha.
Where the hell have you been my whole career, Tim?
Yeah, right. Is that how y'all do POCs? Like splat the network and then be like, look, you got this, and this wrong. Buy our product.
It actually is. So we do proof of concepts like that. And what happens is people are shocked to find that with their existing monitoring software, they don't really know their network. Yeah. Because what we will do in many cases is we'll deploy and then say, did you realize this session border controller is running 100 meg half duplex? And there's a little bit of embarrassed conversation, but you see it magically bloop, full duplex. And it's like, okay, that got fixed in 30 seconds because you were embarrassed about it.
Yeah.
But on the other hand, the POC means you're going to start improving your network from day one.
Right.
And that's really the value. Know your network.
I was going to ask, my follow-up question was going to be, and how many butthurt engineers do you get whenever it shows silly misconfigurations like that? Because I know I would be like, oh, crap. Dang it.
So yeah, there is a little bit of embarrassment that happens occasionally.
Yeah.
But on the other hand, enlightenment is actually a far more valuable feeling than embarrassment. So that tends to work to our favor.
Nice. That sounds like an awesome strategy, honestly.
Tim, are there any of these feature sets that we haven't touched on that you think are important that we should warrant some more conversation on?
I did want to finish one last follow-up on the automation part. If you do have large-scale automations, like, for example, you have 100 lines of ACL that you want to put through on all of the Cisco Nexus switches in the Chicago data center, you can do that with one fell swoop. So large scale deployment changes can be done with the product as well.
So does that go along with like I think Tim was hitting on earlier, basically like a config audit, like if I don't, I'm going blank, but like if you had certain VLANs on a switch, right, and then when it does its check, it's missing VLAN 30, right? Can it go back and push VLAN 30 back out to that switch, or?
So we don't do gold level checking.
Gold level, there you go.
But that is actually on our roadmap. So
okay.
Are you sneaking into our documents?
No.
No, that is on our roadmap. That is something that we figure we're so close to that we can taste it because we have all of the other information.
Yeah.
So having that gold level config is one of our very next features.
Okay. All right.
So hold on. This is exciting. So it's not just monitoring, it's not just intelligence, looking at all the big data and intuiting things from it. But if I have to go out and change an SNM, well, let me think of a better example. If I have to change, I don't know, a banner of the day on 500 devices, I can push that change out with your solution. So
and you can do it to select switches or switches that have a certain operating system on them, or slice and dice however you want.
So instead of learning Ansible and Python and YAML and playbooks, and because
I knew that's where that was going.
well, it just sounds so much easier. I've experienced the old way of managing a network, and then experienced the automation stuff coming in and having to learn all that. I didn't realize that you could push config changes with your platform as well. It sounds easier than learning all the other stuff that I just said.
Yeah, and in one sense, there is a purpose for Ansible. If you're doing super complex changes where you need huge if-then branches and switch cases, and you're honestly doing programming at that point, then yeah, that's perfect for Ansible. For most, I'm going to say most, meaning 95% of what a network ops person needs to do, we're going to cover those bases.
Gotcha.
That's awesome.
Yeah, I'm excited to see this gold config the feature that you put in there. So you can be like, okay, this is what I want my configs to look like. Now make sure it stays that way. And you have to change it here if you want the actual change to happen, kind of thing.
I wish we could do a demo. Like the audio podcast, I get all excited and they're like, oh, this all that. Like, I want to see it, show me the magic.
Yeah. This thing better look sexy. That's all I got.
Are there a lot of colors?
100% of the front end is all RESTful JSON. So any piece of data you want to pluck out of our tool, and it's all scrapable very easily. We've skinned it, so if you want dark mode, you have that. I mean, it's really designed by network folks for network folks. So it's really, this is what folks want.
I'm so happy you said that it has a dark mode. I know that's so petty and like, whatever.
But so important.
Yeah, it's so awesome whenever a tool has dark mode, to me, at least. You're muted, Tim.
Yeah, I know. I'm trying to think of something to say before I say it.
Oh, I got you. I thought you had started talking already.
No.
I thought he had a stroke.
I was waiting to see if anybody else was going to say something.
Oh yeah, no.
I mean, I think we hit it all, right?
End of day, brain is empty.
This has been hugely informative. I'm
Yeah.
I think people are nuts not to use this. I've never heard of, I'm guessing, I don't know if we want to put this in the episode. I'm guessing you have competitors. I've never heard of a solution that's doing what you're offering.
So in one sense, I'm going to say, and this might sound a little arrogant, but in one sense, I think as a company, we're down the path where we're a little bit like Palo Alto. Palo Alto over-engineered their firewalls forever, and they really didn't go to market in early enough time. And so in one sense, we're over-engineered and under-marketed as a company.
Okay.
So as more people start learning about what we're doing, they'll start realizing this is a better way of running a network.
Yeah.
Gotcha. And we'll cut like back before Tim unmuted or whatever. But you're hitting on something I want to ask. Have you heard of what's that one called?
The monitoring solution?
Yeah. But they do sort of the same of what you're talking about, like monitoring all the different links between two devices.
Okay, so there's a couple companies in the market. There's StatSeeker is one.
Okay.
And I'm forgetting what the second one was. They're both Australian companies. And they're monitoring every single interface.
Okay.
The problem is they're not collecting the error counters. They'll give you performance and utilization. They'll give you utilization,
Yeah.
but you could have a collision and not know about it. You could have an
Okay.
FCS error and not know about it. A runt packet, a giant packet, all of those different error counters, symbol errors, and still not be aware of it. So I figure you're not getting the full value with that type of product.
Yeah.
And that's where we figure we're going to pull all the error counters. We're going to be graceful on the network as far as pulling all of that information, and yet put a heuristics engine on top of that that says, let's make sense of this data so that you can solve a problem today.
Gotcha.
This may
So yeah, in one sense, we're like StatSeeker combined with NetBrain for doing the diagramming, combined with NetScout for the analytics, combined with a fluke meter for the fact that we can find physical layer errors.
Yeah.
I mean, we're really a combination of all of these best of breed solutions built into one software deployable capability that's a lot less expensive than all of those other solutions put together.
What is this software called?
Total View.
Total View. So this may be a goofy question, but it's based on an experience I had. So does Total View monitor itself? Like, what monitors the monitoring solution? And what's behind that is we had a router fall over years ago, and we were using NCM, Network Configuration Manager. And I don't know if that's proprietary or not, but that's what we had. And when I went to pull a config, we realized, oh, this hasn't backed up a config in 6 weeks. Uh-oh.
Yeah.
And there was some reason those systems tools gave us, like, oh, I guess that agent stopped running and we restarted or whatever. So I just wonder, we rely on these tools and monitoring and backing up configs and stuff, but how do you know the tool is working or doing its thing? Are there self-checks? Like, I don't know if that's a fair question, but
yeah, no, it's perfectly fair. Is in one sense, something I've learned a long time ago is certain things you need to have positive as well as negative response. You need to know, did this successfully work or did this fail? So backing up configs. If the password changes and we stop getting configs, oh yeah, we're going to alert you and say, hey, we can't get into this device to back a config up.
Good.
If somebody changes a community string on a device, we're not going to send the outage alert, you can't talk to this device anymore. We're going to send SNMP communication failures and say the device still responds to ping, so it's still up, but this is more of an administrative error in the fact that we can't get our data anymore. And so there's different levels of alerts that happen so that it's not an outage. It's just, oh yeah, I changed all those community strings, but I didn't change it on Total View. And another thing is we have it set so that if you do want to change every community string, you go through and say, I'm going to change every community string on the system within 5 minutes and say click and you go. You can also go into Total View and do a bulk change where within 5 minutes you can say, change all of our community strings to use this new string, save, done. So you're not going in, edit device, change community string, save, edit device, change. Oh my God. A lot of tools, they really hamstring you with the administration of the tool.
Yes.
And that's something we're just like, no, don't do that. People don't like that. Add a search and replace capability, add bulk change capability. Good. I mean, in one sense, I'll admit, I'm an engineer. I'm not a marketing guy. I'm not a sales guy. I know where we fit in the market. If you need to do extreme diagramming of a network, then NetBrain might be appropriate. But for 99% of all of what network folks need, we're going to cover the base. Ansible, there's a position in the world for Ansible. There's a purpose for it, and it's incredibly valuable, incredibly powerful. Do most people need to learn how to use it? Probably not. With our tools, they can end up solving the problem, and they don't have to go through a lengthy training session.
Right.
Oh, that's huge. I know we're probably getting toward the end, but I wanted to mention, so it's all about network visibility, right? And something that keeps coming to mind, and we had earlier today, we spoke about this, but I wanted to bring it up here is, I was in an environment that had CSRs and their licenses expired for reasons, right? But nobody knew, right? We didn't have visibility into the network. And if you had gone in the logs, there were thousands of messages saying license expired. Oh my God, bandwidth has dropped. Help me. But we weren't looking. Nobody was calling, right? Like, networks are big. They're complex. There's a lot going on. There's other things you're doing. So, and it reminded me of something Tim said earlier I'd never heard of, like alarm fatigue or whatever it was called. So would what's the name of the product? I forgot it. I'm sorry. Total View. Would Total View know that if a license expires on a CSR or any licensed device, does that just automatically, because if it's sending me every darn alarm, it's crazy. Right now I'm fatigued and I'm not looking, but can I set thresholds? Like, would you have caught that and let me know? Because it was down for a month the bandwidth because it expired. We didn't find out till somebody pushed a big file, and then it was a big nightmare. And then people are like, well, why didn't we know? But we just didn't have the visibility. And this was a big old company. So would TotalView have caught that? Would I have to set a threshold for that, like for licensing type thing?
So I think there's two ways, not knowing all the technical details, but there's two ways of catching that. And one would be syslog alerts, is being able to say, if we see any syslog that comes in with the word license, I think that's something that you'd want to know about.
Yeah.
So if those came in and those were just splatting like crazy, you're going to say, why are we getting these where we weren't getting them before? And so that's one part of the picture. The second part, though, is if those interfaces, you say, gee, these are gig interfaces, they should be able to pump a gig. But I think you mentioned that they were only passing 1 meg worth of traffic. Okay, we're going to see the packet loss counters on those interfaces go crazy. And we're going to say, hey, as of this time and date, you're going to see every one of those happen, and it's all going to be correlated. So you can say, as of this exact time, we started seeing syslog messages that all had these license errors, and we started seeing packet loss counters on these interfaces that went through the roof like crazy. And those things correlated just means you're going to look at it and say, oh, I now know what happened, because you have the data in front of you. Now, in that case, it sounds like that's probably not something that we would have automated saying, you have a licensing problem and it's dropping the interface bandwidth on these interfaces. But we will have the correlation to make it so that you can spot the two just by looking at it.
Right. Gotcha. Yeah. It's so valuable, because when you're in a big environment managing hundreds or thousands of devices, you're not going in looking at everything, digging around for problems. And if nobody's calling and your monitoring solution hasn't thrown an SNMP alarm, like, okay, I guess everything's fine. So I really wish I've had this tool over my career. We could have caught so many problems before the customer caught it and called,
It's really all about knowing your network to a broader and deeper level than ever before.
Yeah, it's awesome.
All right, Tim, as we start to round this out, is there any last minute thoughts you want to give us on yourself or on TotalView?
If you're interested in learning more about it, you can go to our website, www.PathSolutions.com. We have videos that show more of what we do. We have a sandbox that you can go browse around and actually play with the product. You can contact an engineer, and we'll work with you to set up a 30-day proof of concept. And during that proof of concept, we're going to show you things that you don't know about your network that your other monitoring software is simply unaware of, and really prove our worth during that first 30 days.
So bring I was going to say, bring I don't know. Don't get butthurt whenever they show you that. I was going to say, bring your safety blanket with you. And
your security blanket.
Yeah, security blanket. There you go.
Well, I think we got Dan's parting thought there. Andy, do you have anything left to wrap this up?
No, I really appreciate your time, Tim. It's been really fascinating learning about this. I sincerely mean, I know this is a sponsored episode, but I wish I had access to this network visibility tool in my network engineering career, because it was all very reactive. It wasn't proactive. And I don't feel that we had the intelligence or the visibility in our tools to find things like that. So I can really see you coming in, installing this, and like you said earlier, like, oh guys, there's, even in a POC, right? Like, hey, you got some stuff going on here you might want to look at. It is egg on your face, but you'd rather your company come in, find that for us and help us than a customer calling someday with a problem. So no, this has been really informative, and honestly, I want to see a demo of this. It's just, I'm fascinated by it.
Well, thank you all for joining us here this evening. And to the listeners, if you want to support us some more, check out our Patreon program at patreon.com/artofneteng. Tim Titus, thank you very much for joining us. Check out PathSolutions, and don't turtle your network. Take care now.
Hey everyone, this is AJ. If you like what you heard today, then make sure you subscribe to our podcast on your favorite podcatcher. Smash that bell icon to get notified of all of our future episodes. Also, follow us on Twitter and Instagram. We are at Art of NetEng. That's Art of NETENG. You can also find us on the web at artofnetworkengineering.com, where we post all of our show notes. You can read blog articles from the co-hosts and guests, and also a lot more news and info from the networking world. Thanks for listening.